Okay, so the three log rules are um, the log base b of xy is equal to the log base b of x plus log base b of y. So I'm just gonna, this is gonna be a very dry lesson. I'm just gonna show you the proof for either, the higher level kids should know this. As kids you can watch, you're not getting tested on this. So let's look at the proof. So let's let b to the a equal x, okay? And we're gonna let b to the c equal y. So these are our givens, right? That means that log base b of x equals a, and log base b of y equals c, okay? If I multiply b of a times b of c, then we know from our exponent rules that we have b of a plus c. And we know that because b of a was x and b of c was y, b to the a plus c equals x plus y times y, I apologize. Okay? Now what we're going to do is, let's put this back into logarithms. Now once again, we're going to go back from exponents back into the world of logarithms. So we know that the log base b of x times y is equal to a plus c, right? But a was log base b, and c was log base b y. Hence, this is the proof of the rule. So whenever you see the product, the log of a product, you break it up into the sum. Also, you can do the reverse. When you see the log of x plus the log of y, you can smush it together into x times y. So for example, log base 4, 8, plus log base 4 of 2 is equal to the log base 4 of 8 times 2, or 16. That's how logs rule. Also, you can break it up. So for example, if you see the log, how about log of 300? And so this is how we needed it before. So you would write it as log base 3 plus log base 10. 300 is equal to log base 10 of 3 plus log base 10 of 100. And this should make your life easier. Once again, I'm not asking for this. You have a calculator to do this. But you see it ends up being log base 10 of 3 plus 2. And this was the whole thing. This was the point of it. Because you needed to do this. Once again, technology has just made this completely obsolete and unnecessary, but you do need to know these rules. Okay, let's move on. Please get this done. I'm erasing it. The next rule is the log base b of x divided by y is equal to the log base b of x minus the log base b of y. And we kind of go through the same thing. The same idea. B of a, let's keep the old thing. So b of a divided by b of c is equal to b of a minus c, which was x divided by y. We're still using the formulas or the equations we set up for the first one. This is x divided by y. So we have, so we have the log of base b of x divided by y is equal to a minus c. And so we have the log of base b of x divided by y is equal to the log of base b of x minus the log of base b of y. this shouldn't surprise you that division corresponds with subtraction with exponents. Exponents and logs are just inverses of each other, so it would make sense. This is the formula. So, same idea. You're getting problems where they would say, for example, the log base 5 of 200 minus the log base 5 of 8. These are things that show up in science and stuff. So they needed ways to figure these out. And so they would say, okay, subtraction. What does the rule say? Log base 5 of 200 divided by 8. What is 200 divided by 8? Well, we know that it's log base 5 of 25, and the final answer, 5 to what power gives me 25? It's 2. It's nice and pretty. So that's the second rule. Once again, calculators can do this for you, and yeah. So the last rule is the rule we're really interested in. So copy the notes down. Once again, this is just a proof. I'm not asking you for proof. You're never going to be asked this on a test. You are going to be expected to know how to use the rules. Last rule, the power rule. The power rule is kind of interesting. It's really great. It's saying log base b of x to the c. What logarithms allow you to do is take the c down, and now we've freed c from its prison. This is equal to c log base b of x. That's kind of cool, because now we can solve that problem over there. Before when we had 2 to the x equals 12, if I take the log of both sides, this brings the x down, and now I can simply solve for x. Unfortunately, it's 2020 and the technology does this for you, but we'll go through the rule. There's 2 proofs, I guess. If you look at this one, the first way of looking at it is that this actually can be written as log base b of, x times x times x, c times. So you could technically write it as log of base b, x plus log of base b, x, and so on. And so the final answer ends up being c log base b of x. That's one proof that I'm not testing you on. You should just know it. Another proof, a fancier proof, this is proof 1. A fancier proof would look like this. So we know that so this is proof 2. We know that b to the a equals x, right? I'm going to raise both sides to the power of c. Now, we know that this is log base b of x equals a, but we now know that this is what? This is log base b of x to the c equals ac. And therefore, where our proof is done, right? So the log of base b of x to the c is actually c, right? And we're going to move this in there, and we're done. We have log base b of x. And that's the proof. That I'm not testing you on, it's fine. It's just how we prove things in math. And so, for example, let's do a basic problem. Let's do an SL problem, and then we'll do a slightly advanced. So, for example, if I say log base 5 of 25, you would say either you could you could visually see it's 5 squared, or you could rewrite this as log base 5 of 5 squared, right? Bring the 2 down. And then you know that log base 5, that's 1. Final answer is 2. I might ask, so this is an SL problem. How about an HL1? try this one. Log base 8 of 16. How are you going to figure that one out? Well, you have a couple of options. Yeah, you have a couple of options. You can use the power rule. You can use the product rule. Yeah, it's kind of cool, right? I would immediately recognize 16 as 8, right? What is 16? That's 8 to the third power to the fourth. That's 8. The cube root of 8 is 2, and that to the fourth power takes me to 16. Final answer, 4/3. When I come back, we're just going to do some problems on the board, and then another thing. I have a meeting. I'll be back.